So let's practice drawing our Lewis structures. So I'm going to go through a couple of steps, and you're going to want to do these steps every single time. When I draw my Lewis structures, I go through these steps, okay? So you need to go through these steps every single time. And for me, the best way to kind of teach you the steps is to kind of teach them to you as we do an example. So we're going to draw the Lewis structure for HNO3. Okay, so we're going to draw the Lewis structure for HNO3, and that's going to help us to practice our steps. So what's the first step? So the first step is to write the skeletal structure. Just kind of take our pieces, think about this as a puzzle, take our pieces of our puzzle and kind of lay them out on the board. We're not putting them together, we're not connecting anything, we're just kind of sorting our pieces. So there's a few rules that we need to know when trying to decide how to sort our pieces. Hydrogen is always terminal. Terminal means it's going to be on the end, on the outside. If I am in an oxy acid, which we haven't got to yet, but if it's an oxy acid, H is going to be outside, attached to oxygen. So if I'm in oxy acid, H is going to be attached outside to a oxy acid. In this chapter, I'll tell you if it's an oxy acid. When we start talking about oxy acids, then you'll have to know. Who's going to go in the middle? This is what we talked about electronegativity. The least negative atom goes in the middle. So remember, electronegativity increases when we go up and to the right. Because remember, fluorine, which is right here, in the top right corner is the most electronegative atom. All right, so if I look here, I want to write my skeletal structure. So I have H, N, and O. Well, H can't be the central atom, because that's this rule. So I need to figure out if N or O is going to be the central atom. So I go to my periodic table. Whoop. It's not pulling up, there we go. And I say, who is more electronegative? Oxygen is more electronegative than nitrogen. The least electronegative goes in the middle. So nitrogen is less electronegative than oxygen, so he's going to go in the middle. So he's my central atom. And so if he's in the middle, the O's are going to go around him. You could put it however you want. If you wanted to make it like where it's like a triangle like this, that's fine. Exactly how you draw the 2D picture doesn't matter, like shape-wise right now. As long as you get who's in the middle and how they're attached and where all the electrons go, that's what matters. Now we've got to figure out the H. So I'm going to tell you this is an oxy acid. So this is an oxy acid. So if I tell you that this is an oxy acid, that means the H is outside attached to an oxygen. So we got to pick an oxygen, doesn't matter, and he doesn't go in the middle, he goes on the outside. So that would be my skeletal structure. Step 2 is to count the valence electrons. So I want to add everything up. So my compound is HNO3. I have 1 hydrogen, 1 nitrogen, and I have 3 oxygens. So I want to add up their valence electrons. So I go to my periodic table. H is in group 1, so he's 1 valence. Nitrogen is in group 5, so he has 5 valence. Oxygen's in group 6, so he has 6 valence. So if you don't remember, here, I'll write it up here. 1, 2, 3, 4, 5, 6, 7, 8. That's how many valence electrons I have for those columns. Okay? So hydrogen has 1. Nitrogen has 5. Oxygen has 6. I add that up and I get 24 electrons. So we want to sum the valence electrons for each atom. Now, this is talking about if there was a charge. So say there was like a negative or a positive charge right here. It's neutral, so I don't have to worry about it. If there was a negative charge, then I would add 1 electron for every negative charge. If it was a positive charge, then I would subtract an electron for every charge. Now, here's the big kind of helpful hint for you, is that when you're doing these, your numbers are going to become even. Odd electron species do exist, but they're very rare, and we won't have you draw those. So you want to be able to get a even number there, and that's how you know if you're doing it correctly. All right, next step. Now, this step is to attach the central atom to the atoms, and we're going to subtract our pairs of electrons. So this is just another way you could say this is make single bonds. Attach everybody together in a single bond. So I copy over my skeletal structure. So HNO, and I had 24 electrons. Okay? So everybody gets a single bond. Where I had everybody attached, the way I laid them all out, I give everybody a single bond. But now when I wrote a single bond, I wrote an electron. How many electrons did we say was in a single bond? 2. So 2, 2, 2, and 2. So how many electrons did I just write? I wrote 8. I can only write 24 electrons. It's really important to keep track because sometimes people just get excited and they just draw them and then you've made up electrons or you didn't use them all. So you want to keep track of your electrons. So I used 8, I drew 8 electrons. Because remember there's 2 being shared here, 2, 2, and 2. So now I only have 16 electrons left. All right, next step. So I'll just copy that over. Okay, step 4 is to complete the octets outside in. So make everybody happy the furthest away from the central atom. Make him happy, then make the next layer happy, and then we'll get to. So make everybody happy from the outside in, okay? So when we look at hydrogen, remember hydrogen is an exception. And he is complete with 2 electrons. So remember, he's happy with 2. So when I look at this and I say, well, he's got 2 electrons. He's got 2 he's sharing, so he's happy because he has 2. So we don't do anything. Now we look at this oxygen. Oxygen wants 8. How many does he have? He's got 2 here and 2 here. So he has 2 here, 2 here, that's 4. So he has 4 electrons, so to get to 8, he wants 4 more. So what I do is I give him 4 electrons. The way that we draw the electrons are with dots. So I draw them and they're always going to be paired. So now he has 1, 2, 3, 4, 5, 6, 7, 8. And since I put 4 up there, I want to make sure that I notate that I wrote 4 up there. All right, now I do the next one. This oxygen, he has 2 electrons. He wants 8. So that means he needs 6 more. This guy and this guy are the same. They both want 6. So I'm going to give him 6 and I'm going to give him 6. So give him 6 and make sure you draw your electrons nice and dark and make it obvious. So now that is 12. I don't have any electrons left. All right, so this is step 4 is to make everybody but the central guy happy. So everybody's happy, we worry about the central guy next. Next step is the central guy. All right, now we either do step 5 or 6. It depends on where we're at right now. So right now we are here. With 0 electrons left. So the next thing is to make the nitrogen happy. So this is where we have to decide how do we do it. If all the octets are happy and we have electrons left, step 5 says if there was electrons left, give it to the central guy. So let's look at nitrogen. Is he happy? Is he complete? He wants 8. He has 1, 2, 3, 4, 5, 6. So he wants 2 more electrons. So step 5 would say if I had to, just put it on there. But I can't do step 5 because I don't have it. But that's where step 5 comes into play. If you have electrons, extra electrons go to the central atom. Right? This is also where we might do some expanded octets if I have extra electrons. Okay, so expanded octets, and these are elements in period 3 and below. Okay? So that means I can't do that. All right, so I don't have any more electrons electrons, so how do I make the central guy happy? This is step 6. Step 6 says to move electrons. So I'm going to move electrons, take some electrons, and make a double bond. So you can think about step 6 as making double bonds. So we're going to bring in electrons. So this is going to move electrons. You can think about this as make double bonds. Now, in this case, we got some choices, right? Because this oxygen looks different than this one. These two are the same. So I have this choice, which we'll say is choice A, and this choice and this choice are the same. They're both B. So if I'm going to follow choice A, so let's draw what choice A would look like. I would take these electrons and I would move them. So now instead of them being on just the oxygen, they're shared. So those electrons are going to make a double bond. Nothing else on the other ones change. These two stay the same. These two move, and I make a double bond. Oxygen still has 8. 1, 2, 3, 4, 5, 6, 7, 8. But now nitrogen has 8. 1, 2, 3, 4, 5, 6, 7, 8. That's choice A. If it was choice B would say just take one of them. It doesn't matter. It's the same actually. And move from there. Okay, so move these, make a double bond. He's got 1, 2, 3, 4, 5, 6, 7, 8. Now the nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now we have to decide which one do we want to do. Do we want to do choice A or choice B? And one of these is going to be more stable than the other. And to figure this out, we're going to use formal charge. But we're going to stop here because this is a lot of steps. So I want us to practice doing these up to this choice step. And sometimes you don't have a choice. Sometimes your choices are the same and you just pick one and you're done. Okay? But sometimes you have a choice. And so what I want to do is on the next couple of lectures, we're just going to practice problems running through these first 6 steps. And then we're going to go through step 7, which helps us decide if is it A or B. That's our last little step.